because there's a button on the calculator we need to use. So, just finishing that up. So 19 is where we did some very much like this over here. 25 and 35 are very much like these three over here. So we've already done one like this, but just to remember, because it's been several days. So what we are given here is we're given a trig function and a value. And I need to do attendance or I will forget. Sorry a second. It'll come back. Boop, boop. There we go. Otherwise I will forget. And we are asked to find these values. So cosine of 0.42, first things first, is that degree or is that radian?
Degree? No. Radian.
It's in radians. The degrees will always have the symbol. So that's in radians. So you need to make sure your calculator is in radian mode, which I will show you again where to do that on the yellow ones here in just a second. I'm just getting our appendix. Sweet. Okay. Oh, screen's doing things. There we go. Okay. So if we're looking for cosine of 0.42, what we're going to need to do is in our calculator, we need to make sure we're in radian mode. Right now, this is in degrees. You can see it by the little DEG up there. So we go to mode, which is the top center button, and then you need to get over to radians. And you can either hit clear to get out of that, or you can hit the mode button to get back out of the menu. But we need to be in radian mode in order to do this. So to find that value, the cosine of our 0.42, we can type that in. And we get 0.913-ish. So if we're given a straightforward value, we can type it in the calculator. Even if we're given something like secant, which is the reciprocal of that, we can take 1 over 0.913. And we can type that in the calculator and get that. So we can get those values. The one I hadn't shown you is how to do it backwards, the wrong way around. So if I have sine of some angle that gives me 0.75, I want to find theta. That's what we're trying to find. We're trying to figure out this angle here. So what we need to do is we need to unsign it. We're trying to undo that calculation. So it's actually a button on the calculator. And it's one I think I mentioned on Friday, but we didn't actually look at them. So this is having us do sine of 0.7, or sine of some angle gives us 0.75. And what we're going to do is actually an inverse, because I want to unsign it. So we are going to do the inverse sine. That theta is the inverse of sine, so we say that as sine inverse of 0.75. We're just undoing the sign. And again, it's a button on the calculator. So if you look at the sine button down here, right above it in the little green letters is the inverse sign. It's super tiny on my screen. So you're going to hit the green button, then we're going to hit sine, and it gives us our inverse sine, and we're trying to do 0.75. So the angle that gives us 0.75 is 0.848 in radians. So our theta is 0.848 radians. So you don't have to write radians, but I'm just putting it up there to make sure it's clear. If it doesn't have a indication on it, that tells us that it's radians automatically. And the same thing exists there for the other functions. Tangent has one too. I can do the inverse tangent to get what theta is over here. So theta is, I need to untangent, undo it, of 2. It's like if I was trying to divide both sides by something, I'm untangenting. I'm undoing it. So again, it's a button on the calculator. So we've got our tangent button here. We can do our inverse tangent, so it untangents. I genuinely have no idea what I was supposed to put in there. 2. So we're inverse tangenting 2. And so the angle on that, yes, dear.
What would you do for like cosecant or secant?
I'll show you that. We got the last one's one of those. Okay, so our inverse tangent of 2 is 1.107. And again, it's in radians. So our theta is 1.107. So if we have something like secant, which one is secant related to? Cosine. Yeah, it's 1 over cosine of theta is our 3.4. So you can either, I think it's probably easiest to flip it now, or you can flip it at the end. We could also write this as cosine of theta is 1 over 3.4. Which we can get in the calculator, or we can type it in as a fraction when we do our inverse. So to do theta, we're going to take our inverse of cosine of that 1 over 3.4, the reciprocal. So we're going to do the inverse of cosine of 1 over 3.4. You don't even have to calculate what the reciprocal is. You can, but it's not a very pleasant number. And we're going to get a value. Again, it's in radians, so it's our 1.272-ish. 1.272 radians. Okay. So I know that 25 and 35 were very much like that. And then some of them are in radians and some of them are in degrees. So you're just going to have to be careful on your modes. You can do them in degree mode. You can do them in radian mode. Mine are all here in radians. And if I do my inverse sign here, it gives us radians because we're in radian mode. If I did this exact same problem in degree mode, it would give me the degrees. Okay? We just hadn't done any that required that inverse, so I wanted to make sure we got a chance to practice that. I'm sorry, that's why I was kind of running around at the beginning on that one. It's not going to be something that we use tons and tons at this point, but I wanted to touch on it because it's going to come back to us later on. So it's in this homework, but then we're not going to use it super frequently until we get to 6.7. We'll use it more there. Okay. Questions on that bit? Because that's how we're going to end out 6.4. That's the rest of 6.4. With 6.4. There's more sections than that. Okay. Cool. So I'm going to pass out a couple of things to us real quick. I want to pass back your unit circle quizzes. I've got them in if you got a 10. I didn't put in zeros on this one because it's either 10 or 0. Those are the only options on this. So I put in the 10s. I did not put on the zeros on this one. After the second one, which we will do on Wednesday.
Oh, why Wednesday?
Because we're going to do quiz 2 tomorrow.
What?
To be fair, it was originally scheduled for Friday. I have the review. I promise I'm going to get us there. Okay, we're going to do quiz 2 tomorrow. We'll be okay. I promise we'll be okay. Quiz 2's not a bad one. Like quiz 1 was way worse than quiz 2. Quiz 2's not as bad. Okay, so I'm gonna pass out your unit circles. I'm gonna pass out some graphs. We are gonna start graphing these trig functions. So, and then at the end, I'll give you guys I did make a review for quiz 2, so you can have that. I'll get the answer key up today. Just one of those schedules adjusted, and I got to it on Friday, and I was like, oh no. Okay, so I'm gonna pass out graphs first, so you can glue those in, and then I'll pass out everybody's unit circles. And then at the end, I'll give you guys your Quiz 1 is also graded and in. I still have a couple people that haven't taken it yet, so I can't pass it back to you yet. All right, so I'm going to pass out our unit circles. I want you to put these in your notebooks. I'm going to just pass out everybody's unit circles. This is 6.5, yes.
I get so mad. It's going to be.
Oh, yeah, I have my ballistics.
I should have just wrote it in right when you go. It's not. It's not. No, I'm just gonna get it. And I have 30 seconds left.
That should be all our unit
30
circles.
seconds. Like, it'll be different if I have like no time. But I have 30 seconds left.
Ouch.
It's the time that I was in the body. Right here.
I was gonna say,
You.
the first unit circle is always a bit of a rough one.
There's
So close, man. Come on. Oh, boo, my straw has a hole in it. All right. Okay, so what we're going to do today is we're going to look at graphing sine and what that's going to look like. We are going to use this kind of shaped graph simply because it's usually easier for us to see with. It's a lot wider than we're normally used to seeing a graph, but it's the exact same things. It's x's and y's. It's just dots instead of a grid because we're going to have all kinds of weird things. Okay, so our first thing we need to do is we need to get our parent function. We need to figure out what sine of x is going to even look like. So we know a lot of values of sine. We have that whole unit circle to begin with. So our x's really are that angle. And we tend to do these in radians. So I'm not going to necessarily count this as 1, 2, 3, 4, because that's not how we count our angles. We count them usually as like 0, pi over 2, pi, 3 pi over 2, that kind of guy. But I'd even like a little bit more space than that on this graph, especially since it's our first one. So I'm actually going to count this by pi over 4. So I'm going to label my x's, and I'm going to make them kind of small. So I'm going to call this one pi over 4. This one's going to be our pi over 2. This one's 3 pi over 4. And then this one's just going to be pi. And then I don't want to have to number absolutely every single one. So I've got this being 1, 2, 3, 4 things to a pi, right? So 1, 2, 3, 4. This guy's 2 pi. 1, 2, 3, 4. 3 pi. We can also go the other direction and go minus pi over 4. What's up? Oh, I'm so good at counting. That means that one's off too. 1, 2, 3, 4. That one, 2 pi. There we go. This one's 3 pi over 2. So we can do our minuses as well. Minus pi over 2. Minus pi. Minus 3 pi over 2. Minus 2 pi. I can go the wrong way around my circle. And again, we're not necessarily going to number each one of them. More often than not, I will just put the pi's on there simply because it gets really crowded. But since we're doing this for the first time, I'm going to have them all up there so we can see stuff. So there's some values of sine that we know. We're going to think about our unit circle, or you can look at the one that you have. Most of us have these guys right. So at angle 0, so if we're right here on 0, what is the value of sine? 0. Because remember, that's our y values on those ordered pairs. So at angle 0, sine is 0. What is the value of sine at pi over 2? And pi over 2. So if I was at angle pi, we'd be 180 over. So our ordered pair is 0, 1. So which one's sine? So 1. So pi over 2 is at 1. Just think back through our unit circle. I'm just going to have this little sketchy one up here. So angle 0 is this guy, which is at our point 1, 0. So our sine was 0. Pi over 2, that's this guy up here. So this was at 0, 1. What do we get at pi? What is it? 0. Remember our ordered pair, -1, 0. It's the y's. We're looking at that 0. So it goes back down. What about for 3 pi over 2? -1. What about 2 pi? Because 2 pi goes all the way around, right? So it's right back here. 0. Mm-hmm. Oh, nope. You're right. You're right. Sorry. I was just like totally missed the fact that I have my number directly over that dot. It's Monday. It's early. And I just found out my straw had a hole in it, so I just took my straw out. I like sprayed water halfway across my desk. Super fun. So we could even go further. What is another pi over 2 past 2 pi going to be?
1.
It's going to be back up at 1. What about if I did negative pi over 2? What's that going to be if I go this way?
Oh.
If I go the wrong way?
-1.
-1. We're going to wind up back down here. So this goes back and forth between zeros and ones
That's nice.
the whole way across. So this, I'm gonna get a pen that's chunky, but not too chunky. This is what sine looks like, and it continues going back and forth like this. It's a squiggle. It's a sine function. It's called a sine curve. And it repeats itself. If we started at 0, where does it start repeating itself again? Where do we get a repeat of the exact same cycle? I was going to say, if we go to pi, we get the top half. Then we've got a bottom half. So it goes all the way to 2 pi. That's one cycle. It does the top, it does the bottom, right? That is how it goes all the way around the circle, because then it repeats itself as it goes around again, and it repeats itself as it goes around again. That cycle is called a period. This is one period. And this period, it'll have a length. That's usually what we talk about. The length of this period is where that cycle starts, and where that cycle ends is 2 pi, is the length of it. What is the domain of the sine function? All real numbers. We usually put this in our interval notation. So we're going to use our negative infinity to positive infinity. So this goes from negative infinity to positive infinity. What's the range? Negative 1 to 1. So our smallest value, our biggest value. Are we parentheses or brackets? Brackets on both. That range is also the reason why when we're looking at those ordered pairs and the points, we can't just take, like when we had, say on the quiz where we had that like -2, 5 kind of guy, I can't just say that my sine is 5, because the range of sine goes from -1 to +1. That's why we always did it as the triangle with that ratio. Okay? I know we hadn't talked about the range of sine yet, but that's why we did that. Okay? So when we're looking at this LEP and REP, we're going to use that when we're talking about transformations, because we're going to have to transform these things. Oh my gosh. And what they are is where we're starting. So the first point we ever did on here was 0. So our left endpoint is 0. Our right endpoint is the end of the period. So in this case, it's 2 pi. Another kind of thing we're going to talk about is something called amplitude, which I don't have it written up here.
Does the period always start from 0?
Say it again?
Does the period always start from 0?
No. The period will always start from our left endpoint, whatever our first piece is. With sine, it should be 0. I was like, I don't know that we're introducing any horizontal shifting today. Okay, so if we have a horizontal shift, it can shift that, and I'll show you what that looks like. What's up, Anthony?
I thought that for a second. What is LEP and REP?
Left endpoint, right endpoint. I don't have space to write out the whole words. Yeah, left side will be where we start, our first piece. The right endpoint is the end of that first period. So how it would go all the way around the circle. And we're going to have something called the amplitude as well, that we'll see in a minute. And amplitude is very much like when we would have stretch or compress back in our polynomial days. And it's talking about how high those points are. So this guy went up to 1 or down to -1. So the absolute value, or so the amplitude on this one is 1, the number 1.
So it's the distance.
It's the distance from that center line to the highest point. And I know right now it feels kind of gibberishy. Once we start looking at transformation, where these pieces are coming from will make a little bit more sense. Amplitude is going to be like our A. And the very first thing we're going to do is play with amplitude changes. When we start getting into more shifting, we will move where the center is. So just to give us a word for it, it is right now our x-axis, this guy. This is the middle. It's the midline. That's how I saw it. Midline. Honestly, we don't necessarily need to graph the midline, but when we do something like a vertical shift, that helps to know where it's going to go. Because if I needed to shift that up 1 or up 3, it's going to move the whole graph. It shifts the midline up 3. So we just have to be careful with that. So what we're going to do is we're going to start looking at an amplitude change. That's our first graph. And I'm going to change this so we can see it. Okay. It's going to have all the transformation, like the full transformation form up here. So I don't want you to freak out. And it's going to have 3 equations on here. So we're going to start with our amplitude changes. So this is what the transformation form with our like A, H, K, and B, that's what it'll look like. H has that same job, our horizontal shift. K has that same job, our vertical shift. A works just like A did on our polynomials and such, our polynomials and rationals and all those things, but this time it's just our amplitude. So it just has like an actual name now. And so we're going to graph f of x, which is our parent function again, because it's excellent practice for us. We're going to do 3 sine of x, and we're going to do 1/2 sine of x. And what this is going to do is change our amplitude. So it's not going to change any of the length of anything else. So I'm going to count my x-axis exactly the same way. I'm going to do 4 steps for a pi. So 1, 2, 3, 4 gives me a pi. 1, 2, 3, 4 gives me 2 pi. 1, 2, 3, 4 gives me minus pi. 1, 2, 3, 4 gives me minus 2 pi. A lot of times I will just number it like this, or I'll even only label between 0 and pi and just continue counting outwards from there. As long as it's clear what your x-axis is labeled, you can count it however you darn well please. I highly recommend pi-based counting because it'll make your plotting significantly easier than counting by like real numbers. If I counted by 1, 2, 3, I'd have to figure out where pi is to plot my point. Ew. So I'm going to do sine. I'm going to put sine in kind of a dark gray, just so that we can see it, but it's not super there. So I'm going to put f of x, my sine, in a gray. And that's one we just did. So at 0, we were at 0. At pi over 2, we're at 1. At pi, we're at 0. At 3 pi over 2, we're at minus 1. And then it's going to start to repeat itself. And it goes outwards. When we are drawing trig function graphs, it is super important that you graph at least 2 full cycles. It can be more, but we are going to want to include at least 2 full cycles. I will show you how to figure out if we need to change things when it comes time to do so. Because there will be times when we have to count our x's differently simply because of how transformations have happened. That feels really close. Oh, I did that wrong. Boop. I missed a piece there. I skipped a 0. I'm like, that was too tight. There we go. It's really easy to miss pieces. The more times we graph it, the more confident we'll get in it. But that's what our sine curve looks like. It does continue on. And what we're looking at here on our next couple of transformations is changing the A, changing our amplitude. On sine of x, our normal one, there's a 1 in front. That's where the A is. That's where our amplitude is. And what that tells us is how high these pieces are from our midline. So that one was out 1. If we look at g of x, this guy, instead of going out 1, it's going to go out 3. So we're taking all of our y values and we're multiplying them by 3. So our 0 is still going to be 0. But when I'm looking at what was 1, now it's 3. So it's going to be up here at 3. Our 0 is still 0. My 3 pi over 2 is now going to be down at negative 3. 3. Negative 3, 0. Positive 3, 0. Negative 3. So it looks like this. Okay. So the thing that changed here was our amplitude. Our amplitude is 3. It's how far from the midline we go. How high the bumps, how low the bumps. This still has an amplitude of 3, even though it's down.
Amplitude can't be negative.
The amplitude is like, the amplitude is 3. Even if it had a like minus 3 out front, like we can have a negative value in front, the amplitude would still be 3. It would just flip it. So we would still take our 1 times that A. So if we had, theoretical, not doing the whole thing, if I had like, say, negative 2 sine, I would take my 1 times negative 2. So it would go this way. Okay? We'll see that eventually. You're just asking questions about it. It's smidge early, but I love it. I love it. Fully support the inquisition. Inquisitiveness, not inquisition. All right. So on h of x, very similarly, instead of multiplying by 3, we're going to multiply by 1/2. So our amplitude is going to be smaller. So again, my zeros are going to stay the same, but my y, instead of being at 1, is going to be at half. 0, half, 0, half, 0, half, 0, half. And it's going to look like this. So again, A is very much like that stretch or compress, same vibe. If it's bigger than 1, we get a stretch, it makes it bigger. If it is smaller than 1, we get a compress. It looks like somebody squished it. The amplitude itself, we usually write it at like, if it says amplitude and then it has a blank, it'll be the absolute value of A. Because we can have a negative A value, but the amplitude, it's like measuring distance. It's only going to be positive. Okay. We will look at one more kind of transformation today, and then I'll get you guys to review for the quiz. So we've done A change. The next one we're going to do is a B change. Because A does our amplitude, and that talks about the height. And then we're going to do a B change. This will be the end for today. And what B changes is actually the period length. So I'm going to again put our f of x up here, the parent function, just so we can see it. I know it's not listed over here. This will be the last set we do today. So I'm again going to have my 1, 2, 3, 4, pi. I'm going to count this one by pi's because we're going to start from our parent function to see what happens, just so everybody matches. Minus pi minus 2 pi. So our parent, we usually start at 0, which I need that gray again. 0, 1, 0, minus 1, 0. We do want to connect this as a curve, not like a point. It's not an absolute value. It is a curve. I'm not super petty about it, but don't make it something that looks like we could use a ruler. There's our parent function. I straight up missed that last piece. There we go. There's our parent function. So B, these pieces that are inside here, looking at this guy, B, changes the period length. And so what it's going to do is it's going to take our normal period of 2 pi, where we started at 0 and we got all the way over to 2 pi. This is the parent's period. And what B does to find our new period, we're going to take that whole cycle, our parent period of 2 pi, and we actually divide it by the absolute value of B. It should only give us positive values, but just in case, doing it as the absolute value is a good idea. I don't know that we are ever given a negative B value, but it's there just in case. So some of them are going to shorten the period, some of them are going to lengthen the period. So if we look at our B of x over here, which I will do B of x in blue. B of x is period. We're going to take our 2 pi and divide it by 4. We divide it by B. What does that simplify down to be? Pi over 2. So B of x is going to fit the whole function between 0 and pi over 2. So it's going to start at 0, it's going to end at 0, and it's going to go up and then back to 0 and then down, back to 0. So it hits 0 in the middle too, so we know it's going to go up and then down. It's going to go up and then down. Up and then down. So having that B value makes the period way smaller. It goes the other direction too. You don't necessarily have to fill in the whole graph again. Remember, we need to include 2 periods. So on this one, I could zoom in significantly closer. I could change this and count by pi over 2s. I could count, I wouldn't recommend by pi over 2s, but I could count by like pi over 8 so that it's zoomed out or zoomed in way, way closer. Sometimes we'll have to shift the other direction. Let's look at P of x real quick. If we take 2 pi and divide it by 1/2, what is 2 pi divided by 1/2? 4 pi, right? So this period is significantly longer. In order to get even one period on here, I'd have to come all the way back to minus 2 pi so that I could stretch all the way up to 2 pi. Oops, if I don't overshoot it. So on something like this one, I would need to change the way I'm counting normally because I want you to include 2 periods for every graph. So this one doesn't fit 2 whole periods. but it does start at 0. It ends at 0. It hits 0 straight in the middle. We start by going up to 1, and then we go down to 1. So it would keep going like this, but this one is big ol', big ol', big ol'. Okay. Okay, I'm gonna stop there. We will continue talking about the other kinds of transformations over the next couple of days. I'm going to put them all up here. I'm gonna put them on the table. Review for the quiz. 6-5, the homework is all graphic. So instead of making you come up with a graph paper and things like that, print it. And with lots of space. We are going to keep working on this tomorrow and probably Wednesday. This is 6-5. Probably going to be due. Wednesday is the very, very earliest. Depends on how much we get through after the quiz tomorrow. More than likely it's going to be Thursday. But it's here. This is 6-5. This is going to be just sines and cosines. Start with just sines and cosines on that. Okay? So they're all up there. You'll have about a minute to the bell. I'm going to put up the page with that stuff.
Why is someone getting pounded on this stuff? Why not so much to do?
Because it's a college course. Especially with the 2-hour delay and with the e-learning day, we lost a whole period that we're just like straight up not getting back. Yes, sir.
So 24 or 25 and 35 minutes are 75 degrees in minutes. Did I do that?
Oh, so it just meaning instead of like 23.21, 23 degrees and some number of minutes.
Okay.
Yeah.